Welcome to our last unit of grade 12 pre-cal, so unit 7, lesson 1. We're going to be doing exponential and logarithmic functions. So today we're going to start with exponential functions and what those look like on graphs, because that will be something that you've actually never seen before. So in terms of manipulating them and our transformation unit, it still very much applies here, but that parent function, that foundational shape, is going to be something that you haven't worked with before. So we'll start with the table of values, and we're going to work with the function of 2 to the power of x. So when we have x equals -3, we're going to calculate 2 to the power of -3, and that gives me 1 over 2 to the power of 3, or 1/8. 2 to the power of -2 would be 1 over 2 to the power of 2, or 1/4. 2 to the power of -1 gives me 1/2. Remembering that anything to the power of 0 is 1, and so forth. 2, 4, and 8. So you'll notice that although we have no non-permissible values per se, I can always put a number in for my exponent. There's no restrictions as to what an exponent can be. It can be a fraction, it can be decimal. So I have no restrictions on my domain. What does happen is that I don't end up ever crossing my y-axis or my x-axis, because when I cross my x-axis, that would mean going into the negatives, and when I have a positive base, that is impossible. There's no way that I can turn a number from a positive to a negative strictly by using the exponent. And because of that, there are no x-intercepts. My y-intercept is when x equals 0, and anything to the power of 0 is 1. So that's going to be consistent no matter what your base is, as long as it's a positive number. And even if it's a negative number in your base, your value is still going to be 1. There are no vertical asymptotes because my domain is not restricted, but because I don't have any x-intercepts and it's impossible for me to cross that x-axis, I do have a horizontal asymptote at y equals 0. And so my range is from 0 all the way up to positive infinity. And we see that when we graph it. And this is our general shape. 1, 2. And we see how fast it increases, 2, 4, and how fast it decreases if we go to -1. We're already at half. So that's our general shape for exponential functions. It's going to be that curve approaching the x-axis, but then increasing greatly and always intercepting at 1. So that's my parent function. To prove this to you, try doing the same thing with this one. So we see when we complete the table of values, the key thing to remember is that when we have a negative in our exponents, that results in a reciprocal of our base. So we go from a half, flip it up to just 2 to the power of 3. And so our values actually are exactly the same as the ones we had in our first example, just in the reverse order. So by using a fraction base, all we're doing is we are essentially accomplishing that we have a reflection over our y-axis. So it has the same impact as introducing a negative in front of that x value. So if I had written this as y equals 2 to the power of -x, it would have had the same effect. So again, we have no x-intercepts because we haven't had a vertical shift at all. We haven't vertically stretched or compressed at all. So no x-intercepts, which means no horizontal or vertical asymptotes. Also, and our domain is still from negative infinity to positive infinity because, again, we're allowed to put anything in that exponent place. Vertically, my y-intercept is still 1 because anything to the power of 0 is 1. Okay, I do have that horizontal asymptote at y equals 0 because there's no way that I can turn something with a base into 0. And so then again, my range is going to extend from 0 to positive infinity. So this graph is going to have similar properties. If you want to pause it and make a table of values and do all of that, again, that's totally fine. I'm going to pause my video now and I'm going to complete all of the, when it says state all of the properties, what it's asking you for is these 5 pieces: the x-intercepts, y-intercept, asymptotes, domain, and range. Okay, so if you need to write that down before you get going, remember x-intercept, y-intercept, asymptotes, domain, and range. Okay, so take a pause, try and graph this one yourself. When you look at this video, or this function, we notice that it is very, very similar to example 1 in that the only thing I've changed is that the base is different. So again, remembering that this is called the base, and then it is bigger, larger base. And the impact that that has on my table of values and my resulting graph is that my y-intercept actually doesn't change at all. So it still ends up being at 1. So that's kind of a cool thing. So that stayed the same. My horizontal asymptote stayed the same. My domain stayed the same. My range stayed the same. And the fact that I don't have an x-intercept also stayed the same. So what is different? Well, how fast my graph grows. And you'll notice that I used a scale of 2 instead of 1 on my vertical axis this time. And the reason that is because my first point has to be at 1, which is halfway. But instead of only just going to 2 to the power, when I'm at the power of 1, I'm actually going all the way up to 4. And I don't even have room, even with adjusting this scale of my axis, I still don't have room to put that second point because it should be all the way up here at 16 for a square. So my graph becomes kind of like stretched out. Vertically. Or I could think of it as compressed horizontally. Because instead of having a quarter showing up at 2, it now shows up over here at 1. Okay, but again, that kind of invariant point thus far has been my y-intercept at 1. Dealing with a fraction, again, remembering that this impact is only going to be like a reflection over y. So I would think, in terms of like a prediction of what my graph is going to look like, it's going to look something like this. So I'm making that L shape instead of the reverse direction. Okay, again, take a pause, make a table of values if you want, define your 5 properties. That's your x-intercept, your y-intercept, your asymptotes, and your domain and range. So if you make a table of values for this, we'll promptly see that, again, we get when x equals 0, this whole thing is still to the power of 0, which means it is 1. So my y-intercept stays 1. I haven't shifted up or down, so my horizontal axis is still at y equals 0. This time I'm just going up to 3 and 9 respectively when I go into my higher points. But you'll notice that I've drawn this backwards because I didn't actually draw a table of values. my error. So if you're like, oh no, I did it wrong, I did it backwards, don't worry, I did. Let me fix that now. So again, -1 and 3. And that's the tricky part about all graphing, is remembering all those little nuances. And even though I specifically knew that my graph was going in that direction, I got carried away with just the rote drawing of exponential curves and did it the backwards way. So making that prediction is never a bad thing, because then you can go back and check your answer and be like, oh yeah, what am I doing? Okay, so in general, now that we've seen a few of them, an exponential function is a function written like this, where a is a positive constant and x is your exponent. So then, in general, what we can say is that when a is greater than 1, or just like a general whole number, or even fractions bigger than 1, you could technically do, you would expect your shape to look like this. Oops. Let me switch back. And the key thing is that y equals 0 is your asymptote, and that your invariant point is 1, your y-intercept. Okay, conversely, if you're dealing with a fraction between 0 and 1, that's when we have that flipped shape we just saw. And so that's going to be this guy, faster curve on the other side of that y-axis though. So again, y-intercept at 1, y equals 0 is my horizontal asymptote. The shape is the same, so it's strictly a reflection. Okay. So when we're looking at the graph on the left, I'm just going to zoom out so we can see this in general. Graph on the left is said to be increasing, graph on the right is said to be decreasing. The graph always has a y-intercept of 1. It approaches the x-axis, but never reaches it, so its horizontal asymptote is at y equals 0. The graph does not have an x-intercept because we have an asymptote there, and the domain is x is the element of the rails, or interval notation, y has to be greater than 0, or 0 to positive infinity. And so these are all things that we established already, but just to reiterate, make sure we've got those down. So that's our first lesson. I'm not going to do homework for this lesson on its own, but you will get some practice later on.